face-centered cubic crystal lattice ABC arrangement. Quite a tongue twister, isn't it? But face-centered cubic FCC lattice is nothing very complicated. It is a simple way of stacking spheres in the densest and the most efficient manner in 3 dimensions. It is the grocer's method of neatly piling up oranges and apples that you end up admiring very often. And also the most efficient way of piling up cannonballs in a battlefield. But have you ever wondered who would have come out with this brilliant idea first? It was Sir Thomas Harriot, a renowned mathematician who was the first one to stack these cannonballs in this intelligent way as early as the 16th century, and who predicted that atoms in crystalline solids were also arranged in the same efficient manner. Let us try to build the FCC lattice of silver starting from a single silver atom. Arrange many such atoms in a single row. Now, make the next row of atoms such that they fit into the depressions of the first row. Go on making the subsequent third and fourth rows of atoms in a similar staggered manner. This layer of spheres is designated as layer A. Each sphere in this layer is in contact with 6 other spheres. If we join the centers of these 6 spheres, a hexagon is formed. Thus, this arrangement is called the hexagonal closed packing in 2 dimensions. This arrangement of atoms results in some empty spaces or voids, which are triangular in shape. Let us label these voids pointing downwards as X and the ones pointing upwards as Y. Now, place the second layer of atoms on layer A such that the atoms in this layer occupy the X voids. Let us call this layer as B. For every 3 spheres of layer A, there is a corresponding sphere of layer B placed above these 3 spheres. This forms a tetrahedron, and this void is thus called a tetrahedral void. Layer B also has X voids and Y voids. Notice that the Y voids of layer A coincide with the X voids of layer B. Let us consider a group of atoms surrounding the X voids of layer B and those surrounding the Y voids of layer A. You can visualize 2 triangles, one having an apex pointing upwards and the other pointing downwards. The void so formed has an octahedral shape. Such a void surrounded by 6 spheres is called an octahedral void. Now, place a third layer of spheres to cover the X voids of layer B. This third layer of spheres is designated as C. Label the voids X and Y of layer C and bring the fourth layer to cover the X voids of C. This fourth layer coincides with the first layer, and we again call it layer A. If you continue stacking layers one above the other in a similar manner, an ABC lattice is formed. If we take out a unit cell from this lattice, it would look something like this. Hence, the ABC arrangement is also called the FCC crystal lattice. The packing efficiency, that is the ratio of the occupied space to the available space, in this arrangement is found to be 74%. As this is far greater than in the AAA arrangement, this arrangement is obviously more efficient. To summarize, we have learned about ABC arrangement in metallic solids and also studied the 2 types of voids, namely tetrahedral and octahedral, formed between them. We also studied that the packing efficiency in the ABC arrangement is 74%, and thus it is the most efficient way of stacking spheres.